Howdy, Internet students. This is Mr. Hermanson again here. This lesson is on Objective 1.1b. Again, you're going to need your 1.1, 1.2 quiz in order to follow along. You can download that from the website if you can't find it in your notebook. All right, so in this objective, we're trying to learn how to classify relationships as direct variations, as linear relationships that are not direct variations, or as nonlinear relationships. Just a reminder here, we'll put this at the top. DV stands for direct variation. A direct variation must have three things. One, it has to be linear, and that means the numbers go up by the same amount or down by the same amount every time. Number two, it must be proportional. What that means is when you divide the y number by the x number, you always get the same amount, the same ratio. And three, and you'll find that this is always true if it's linear and proportional, but it will go through the origin. The line will go through the origin, or the table will start at 0, 0. All right? So, keeping those things in mind, let's do a couple problems. Now remember, origin means the point 0, 0 on the graph. Okay, so this problem says at the beginning of the month, Hannah had nothing in the bank. She started a part-time job and deposited $40 each week. We want to know if this is a direct variation, linear, or not direct, but not a direct variation or nonlinear. I like to use a table to help me figure this out. Our two variables are weeks and how much money she has in the bank. So I'll just put total, meaning total money, a little dollar sign there if you want. And I'll just do a couple weeks here just to see what's going on. Since she started with nothing in the bank, that means at 0 weeks she has $0. And then each week she deposited 40. Deposit means she's putting money in. So after 1 week she now has 40. After 2 weeks she has 80. After 3 weeks she'd have 120. Each week I'm adding another $40. Now, since I went up by 40 each week, this is definitely linear because we're going up by the same amount. So we got number one checked off. It's linear. And then to see if this is a direct variation, you could look at two things. You could say, since it starts at 0, 0, you know it's a direct variation since it goes through the origin. And the other way you could do it is by looking at the ratios of the total amount of money to the number of weeks. 40 divided by 1 equals 40. 80 divided by 2 equals 40. And 120 divided by 3 equals 40. So all these ratios are the same. That means this is a proportional situation. So we're going to say, A, this is a direct variation. All right? Number 2 says at the beginning of the summer, Molly had $1,248 in the bank. Each week she deposited $150. Again, deposit means she's putting the money in. So let's just do a couple weeks here again to see what's going on. Okay? So after 0 weeks, she already has money in the bank. So we're going to start at $1,248. After 1 week, she added $150. That makes the total $1,398. After 2 weeks, she added another $150. That makes the total $1,548. And so on. She's going to keep adding 150. Now, since she's adding 150 every week, that makes the situation linear. But since we're not starting at 0, 0, and you could check this out, but if you divide 1,398 by 1, that equals 1,398. If you divide the next amount, 1,548 by 2, that equals 774. Notice that those are not the same, those ratios do not have the same value, so this is not proportional. But it is linear, So we're going to say B. This is linear, but not a direct variation. All right. Number 3, we're going to look at the graph to help us decide. And linear means that it's going up by the same amount. That would be like a straight line, like this would be linear. And obviously this graph is not a straight line. So we're going to say this is nonlinear. The other thing you should look for on a graph is if it was linear like these dots are, and if the dots went through the origin like this, then it would be a direct variation. So, so to be a direct variation, you have to see the dots all line up, and you have that they go through the origin, 0, 0. Okay, so that's a nonlinear. Now, in the last problem, it says identify equation that is a direct variation. Well, to be a direct variation, it has to be a linear equation. And as we've seen in class, all linear equations look like this. They have some number times x plus something else added on. Okay. Now, if it's going to go through 0, 0, then you can't have anything like this added on. You would just have y equals something times x to be a direct variation. Since that's what we're looking for the equation that just has some number times x. And that would be that one. All right. That should do it here for this lesson. Hope this helps out, and we'll talk to you soon.